In 11.2, we're going to talk about arithmetic sequence, which is a sequence in which each term differs from the preceding term by a constant term d. What we're going to call d is a common difference. Basically, what you're going to be doing is you're going to be adding or subtracting from the previous term. And it doesn't necessarily relate directly to the term itself, but again to the preceding term, unlike the last section that we talked about. To kind of give you an idea what we're talking about, let's look at the first example. We're going to write the first 6 terms of arithmetic sequence whose first term is 5, and whose common difference is 3. So we're trying to find 6 terms. So we'll do a sub 1, a sub 2, 3, 4th term, 5th term, and then the 6th term. We know that the first term is 5, so that starts there. But the key thing is that the common difference is 3. And what that common difference meaning is that we're going to add 3 to the 5. And that will give us the second term, which is 8. Then we add another 3 to the 8, which will give us the third term, which is 11. And then so on. And then you can notice there really isn't a direct relationship between these two, but more so on the adding of 3 from the previous term. Now, if we're trying to find the first 5, 6 terms altogether, that's not a big deal. But if, let's say, we just needed the 100th term, we really wouldn't want to have to write out 99 terms before that. Luckily, there's a general formula for that. We can find a general term of arithmetic sequence by the following. You can do a sub n equals the first term plus the quantity n minus 1 times the common difference. And that can give you any term in the sequence. So let's consider the arithmetic sequence whose first term is 4 and whose common difference is -7. What we want to do first is write an expression for the general term a sub n. So we start with that general formula, and then we can just plug in. To find the general term, we're going to put in the first term, which is 4. We're going to add the quantity n minus 1 times the common difference, which is -7. We're then going to distribute the -7 to the quantity. So it'll be minus 7n plus 7. And then we'll just kind of simplify that a little. 11 minus 7n. And then this right here will give us a general expression for any term within the sequence. Now what we can do is we can take this formula and we can find the 15th term. So if I want to find the 15th term, all I'm going to have to do is plug in 15 for n and then calculate, which will give you -94. So we don't really have to do any calculating. Sorry, that should be the 15th term. That's why I'm going to change that. We don't have to calculate the 14 previous ones, but we can just plug it in once we find what the general equation is. In the third example, we're going to have to do a little bit of work to find the information that we need. It says find the 12th term of the arithmetic sequence whose first 3 terms are 5, 9, and 13. Well, we need to know what the first term is, which is 5, so that helps out. A sub 1 equals 5. But we also need to know the common difference, which they don't give us directly. But we can easily find that. Going to 5 to 9 is adding 4. Going to 9 to 13 is adding 4. And it's constant, so we're going to keep that as our d as 4. So we're going to go back to our general equation. A sub n equals the first term plus the quantity n minus 1 times d. And we'll just plug in. A sub n equals 5 plus n minus 1 times 4. Now, you can go ahead and distribute, get it simplified, or you can plug in right away. I'm going to go ahead and simplify it. And so our general equation would be 1 plus 4n. So now I'm going to take that and I want, let's just double check, the 12th term. So I'm going to ace of 12 equals 1 plus 4 times 12. and that will give me 49. So the 12th term will be 49. Now, number 4 will make us do even more work to find out what we need. It doesn't give us quite as much information as we'd like. If the second term of the arithmetic sequence is 15 and the 6th term is 35, find the 8th term. And what you're going to do with these is you're basically going to set up a systems of equation. You know that the second term is equal to the first term plus 2 minus 1 times that common difference. Then you know that the 6th term is the first term plus 6 minus 1 times that common difference. And then we'll substitute it in. The second term was 15, so it's 15 equals a sub 1 plus 1d, because we just simplified that a little bit. And then we have 35 equals a sub 1 plus 5d. And what you should notice right here is that this is going to be a systems of equations. We have two variables in two equations, so we should be able to figure out what one of the variables is quite easily. So what I'm going to do is I'm going to do subtraction. I'm going to subtract the 2 because this will cancel out right here. I'll get negative 20 equals negative 4d. And so then the common difference is 5. So we'll know that. And what we can do then is that we can plug it in to figure out what the first term is going to be. We won't really need to do this with that one because if I know the second term is 15, we can just kind of subtract 1 or subtract 5 and know that the first term will be 10. So now that I have the two essential information that I need, we're going to put it together and we're actually going to calculate the 8th term. So if I want to know what a sub 8 is, I'm going to do the first term plus 8 minus 1 times that common difference. And that's going to give me 10, and we know that common difference, we know that the common difference is 5. So now I have 7 times 5, which is 35, which will give me 45. So that 8th term will be 45. And finally, our last example, we're going to kind of apply this a little bit to real-world practices. We have going to look at a salary that begins at $45,000 per year with an increase of $1,350 per year for the next 4 years. We're going to write a general term for the arithmetic sequence described. So to write that, again, let's go back to that basic. A sub n equals a sub 1 plus the quantity n minus 1 times d. The common difference right here will be 1350. And a sub 1 is 4,500. If we distribute it, we'll get 4,500 plus 1350n minus 1350. And if we simplify that, that's going to give me $43,650 plus 1350n. And that will give me my general equation for the term. Now, I want to find the salary in the third year. What I would do is just plug in for 3. The third term would be 43,650 plus 1350 times 3. And you would get $47,700.